First we will start with the Z parameters. Now there are various names for the Z parameters. It is also called as the impedance parameters, and another name for it is the open circuit parameters. So we will understand shortly why we have so many names for this particular parameters. The independent variables here are the currents I1 and I2. Okay, so if you draw the two-port network, this is the input port, this is the output port, and the voltages here are V1, current is flowing inside I1, here also current will flow inside I2, and here the voltage is V2. Okay. So now I1 and I2 are the independent variables, and V1 and V2 are dependent variables. That means they will depend on I1 and I2. Okay. So these four parameters will now be related as V1 is equal to Z11 I1 plus Z12 I2. This is one equation, and V2 is equal to Z21 I1 plus Z22 I2. Okay. So now these parameters here Z1, Z12, Z21, Z22, these are called as the Z parameters. If you write in the matrix form, then what are you going to get? V1, V2 is equal to, this is the voltage matrix. Next you have Z11, Z12, Z21, Z22, and the current matrix you can write as I1 and I2. Okay. So now if you multiply this, what will be the first element here? Z11 I1 plus Z12 I2. This is equal to V1. V2 is equal to second column now. So second row now, Z21 I1 plus Z22 I2. Okay. So this is the matrix representation, and this is called as the, this matrix is called as the Z parameter matrix. Now we will see how to obtain these Z parameters. Alright. In equation 1, if you take I2 as 0, then Z11 you will get V1 by I1, right. So that means you can write Z11, you can define Z11 as the ratio of the voltage, the input voltage and the input current under the condition I2 is equal to 0. Okay. So this is called as the open circuit input impedance. So now you might be getting an understanding of why this is called impedance parameters, because it is the ratio of the voltage and current. Z11 you will get as a voltage, as a ratio of voltage and current. So that's why we call them as impedance parameters. And why open circuit parameters? I2 is equal to 0 means what? In this two-port network here, I2 is equal to 0 means the output port you have to keep it open circuited in order to find the Z11, Z12, Z21 and all other Z parameters. So that is why we call them as open circuit parameters. Similarly, now you can write the other parameters. What will be Z12 in the equation 1? I1 if you keep as 0, then you will get Z12 is equal to V1 by I2. This is when I1 is equal to 0. Okay. Then what about Z21? Thus you are going to get V2 by I1 when I2 is equal to 0. And finally, Z22 is equal to V2 by I2 when I1 is equal to 0. If you see the subscripts here, Z11 is the ratio of the voltage and current at the input port. Okay. But Z12 and Z21, if you can see, voltage we are taking of one port and here current we are taking of the second port. Here also Z21 voltage of the second port divided by current in the first port. Okay. So these impedances are called transfer impedances. Okay, because they have a combination of the output and input side quantities. Whereas Z11, this is called as the driving point impedance. Similarly, Z22, this is the voltage and the current both at port 2. So this is also called as the driving point impedance. Okay. So what will be the units? Each of the units of all the parameters, you can see it is the ohms. It is in ohms. Okay. So now this Z11 is the open circuit input impedance, Z12 is the transfer impedance from port 1 to port 2. Okay. And this will be what? Transfer impedance from port 2 to port 1. So this is all just how we name it. Okay. Then what is Z22? This is the open circuit output impedance. Okay. So what are the 2 points that you need to remember here? The units of all parameters are ohms, and we have Z11, Z22 which are called as the driving point impedances, and the other two, which is Z12 and Z21, these are called as the transfer impedances. Now the Z parameters we can represent as an equivalent circuit. Okay, equivalent circuit representation. So how will you do it? Once again you write the equations. V1 is equal to Z11 I1 plus Z12 I2, and V2 is equal to Z21 I1 plus Z22 I2. Okay. So now both these equations, if you see, they are sum of addition of voltages, so we can represent using the series circuits. Okay. So that means elements are in series. Now V1 if you draw, what can you get? You can get a circuit impedance here, Z11. I1 current is flowing here and V1 is the port voltage. What else is left out? Z12 I2, but I2 is flowing in some other circuit, okay, in the output side, right? So here what you can do, you can make use of a dependent voltage source. And what will this be? Z12 I2. Okay. So now we have V1 is equal to the impedance Z11 into current I1 will give you the voltage drop across this. What will be the voltage drop across this dependent source? It will be Z12 I2. It is a current dependent voltage source. Next V2. V2 also we can represent in a similar sense. So here we take a dependent voltage source. What will be the magnitude here? Z21 I1, and the impedance here will be Z22. Okay. So this is voltage V2 and the current flowing through this is I2. Okay. But now this is a complete circuit will be connected together. So that is why we connect these both like this. Okay. So now this is the two-port network. Whatever is inside the two-port network, we can get them to represent in this form. Okay. Next is Y parameters. So this is also called as, this also has other names. One is admittance parameters and another name is short circuit parameters. Okay. So here what are the independent variables? The voltages are independent. V1 and V2 are independent, while I1 and I2 are dependent. In Z parameters it was just the opposite. I1 and I2 were independent, V1 and V2 were the dependent variables, parameters. Okay. So once again let us draw this two-port network. This is the input port. Input side voltage is V1, current I1 is entering. The reason I am saying current is entering so many times is in power systems there is a slight difference when it comes to ABCD parameters. Okay. When we are dealing in networks, usually we take the current to be flowing inside. But during the gate exam, there is no networks, there is no power system separately, right? So that is when you have to remember what is the direction of current, so that some negative sign will not cause a silly mistake. Okay. So here I1 will be written as Y11 V1 plus Y12 V2, and the current I2 is given by y21 V1 plus y22 V2. So these are the two equations. Here y11, y12, y21, y22, these are all the y parameters. So we can write this in the matrix form as well. I1, I2 will be the current matrix, column vector, column matrix, and this will be y11, y12, y21 and y22. This is a 2 by 2 matrix. Okay, and finally the voltage matrix V1 and V2. Now how will you find these y parameters? So in the equation 1, if you see y11, you will get as I1 by V1 when V2 is 0. Only when V2 is 0, the ratio between the current and the voltage will give you the admittance. So what will this be? Will it be driving point admittance or transfer admittance? It should be driving point admittance, input side driving point admittance, because it is the ratio of the current and the voltage on the same side. Okay. Similarly, the other driving point impedance admittance is y22. What will it be? You will get from the second equation. This will be I2 by V2 when V1 is 0. Okay. So now you can see here why it is called admittance parameters, because it is the ratio of current and voltage, and why it is called short circuit parameters, because we are making the voltages 0. So if you V2, if you short circuit here, then you can find the ratio between I1 and V1, so that you will get y11. Because the admittance parameters can be obtained by short circuiting, it is called as the short circuit parameters. Okay. So these both are the driving point admittances. Okay. So this is the output driving point admittance and this is the input driving point admittance. What are the other two parameters? Y12 and Y21. So Y12 will be I1 by V2. So you can simply hear Y12. So on the numerator 1 subscript, on the denominator 2 subscript. And it is admittance parameter. So in the numerator current, the denominator voltage you will have. Okay. So this will be at what condition? The other side voltage should be 0. V1 is equal to 0. What about Y21? This is going to be I2 by V1 when V2 is equal to 0. So these are the transfer admittances. And what are the units of these parameters? They are all in mho. What is the symbol for mho? This is the symbol, or you can also use the Siemens unit. Okay. So 1 mho and 1 Siemens are one and the same. Let us now see the equivalent circuit representation. Okay. So the two equations are, we will rewrite the two equations. I1 is equal to Y11 V1 plus Y12 V2 and I2 is equal to Y21 V1 plus Y22 V2. Okay. So here we have the addition of current. Current is equal to some parameters, some terms. So here you have to use parallel circuits because KCL will be applied in the parallel circuits. In the Z parameters representation, we have taken series elements. Okay. So what is the circuit representation here? V1 and I1 will be as it is. Now inside the two-port network, you will have one element which is Y11, right? So this is the driving point admittance. Now what is the other term? Y12 V2. Okay. Since V2 is not on this side, it should be a dependent source. So we will have a dependent source. What will be the direction of current? It will be away from the node, because according to the equation I1 is equal to some terms. So I1 is equal to the current passing, this is entering, I1 is entering, other currents should leave the node. Okay. So this is going to be Y12 V2. What kind of a dependent source is this? It is a voltage dependent current source. Okay. Then what about the rest of the circuit? On the other side also we apply the same method. So you will get one admittance, which is the driving point admittance Y22, and the current I2 will flow into the two-port network. The voltage here is V2, and here you have a voltage dependent current source once again And what will this be? Y21 V1, and these two you will connect like this. Okay, so this entire thing will be inside the two-port network. Okay, outside we will only be able to see the terminals. Voltage across the terminals is V1, current through the terminals is I1. Here on the other side, V2 and I2. Okay, so till now we have discussed the Z parameters, which is also called as impedance parameters or the open circuit parameters, and the Y parameters is also called as the admittance parameters and short circuit parameters. Now these both together, they are called as immittance parameters. There are many other parameters that you will be learning, but these two together, they are collectively called as the immittance parameters. Finally, one more point here is the conditions for symmetry and reciprocity. So what is meant by symmetry and reciprocity, and what is the condition required for a circuit to be symmetrical and reciprocal? Okay, so we will start with the symmetric network. So a symmetric network, this is nothing but if you divide the two-port network into two halves, then both of them will be identical. Okay, so a symmetric network can be any network through which we can draw a line such that it can divide the network into identical halves. Okay, then what about a reciprocal network? We have discussed one theorem called as the reciprocity theorem. Any circuit which will satisfy the reciprocity theorem, reciprocity condition, it is called as reciprocal network. Now what kind of network will satisfy the reciprocity theorem? Any network consisting of the passive elements will be a reciprocal network. Okay, any network consisting of only R, L and C, resistance, inductor and capacitor. Okay, so these elements should only be present, and this is any network consisting of these elements will be a reciprocal network. Okay, so this basically means that it should have only passive elements. Okay, now what is the condition on the Z parameters and Y parameters? That means using the Z parameters and Y parameters, can we decide whether a particular two-port network is symmetrical or reciprocal? So the symmetric condition is simply the driving point impedances should be same. Similarly, the driving point admittances should be same. So Z11 is equal to Z22 and the Y parameters Y11 is equal to Y22. Okay, so there is a derivation for this as well. If you want, you can go through the textbooks, but it is not necessary for us to know the derivation. The condition is enough as of now. Okay, and what about the reciprocity condition? For a circuit to be reciprocal, the Z parameters, the transfer admittances should be same, admittances and impedances. So that means for the Z parameters, Z12 should be equal to Z21, and for the Y parameters, Y12 is equal to Y21. So these are the two conditions that you need to remember. This is very important. Alright.